When you live in New York City, just waking up in the morning, going out of your apartment and walking to the subway, in those 10 minutes, you're going to see about 1 million people. And things will happen. You're going to overhear short little snippets of conversations, little bits of other people's lives that you kind of weave into and weave out of. And you feel like a part of the human race, like you're participating in life. Part of recruiting a great team is creating a great place for them to work. We were really running out of space in the old office, so we had to scurry. We found a new office space downtown. The space, as usual in New York, is either delivered in terrible condition or completely empty. And so the landlord had offered to pay most of the cost of renovating it and building offices and so forth.
So we've been doing this construction project and dealing with deadlines and completion and estimates and all those things. How do you think this project compares to actually writing software?
Well, it's very, very different when you try to schedule it. So, for example, our construction manager, Kristen, has built offices before, and she's managed this project many, many times in this very building with these very workers. And for her, building some drywall with a side light in it or putting in drop ceilings is something she's done 1 million times. And she knows how long it takes. And when she says it's going to take 2 weeks, that's because she's done it before, and it took 2 weeks the first time, and it took 2 weeks the second time, and it took 2 weeks the third time. When you're building software, you're never doing the same thing again that you've done before, because if you were, you would just reuse that old code. Software is not building, it's not construction, it's design. And design is like exploring a space of possibilities, of what all the possibilities are, and you don't know how long it's going to take. It's like science. You don't know how long it's going to be until you find your solution. So software projects are very, very different to schedule because there's so many unknowns that you should never see in a construction project unless you're doing something really wacky and unusual. Before you do any new work on a software, whether you create a software product or a new software feature, any kind of programming work, you really have to do a cost-benefit analysis. You have to figure out, is it going to be worth the amount of effort that we're going to put into it? Can we make our money back? Is this the best way to spend the next 3 months? Or are there some other things that we could do that would have a lot more bang for the buck, as they say? And the only way to correctly make these kind of analyses is to come up with some kind of a schedule and an estimate of how long it's going to actually take to add a feature or to build a software product. So schedules are essential, really, to making the right decisions. Figuring out how much time certain things are going to take is essential to deciding what things to do and to making the right decisions about those things. And then once you have a schedule, keeping on schedule is really important, or using the schedule kind of as a tool is really important, because that gives you a constant imperative to remove useless junk. Otherwise, there's a real tendency to add a lot of useless junk to your software, a lot of features that aren't really going to be important, that seemed cool at the time but may not be that important, what we call gold plating. And if you're really trying desperately to meet a schedule, and you're like every other software development team in the history of the world, then you're constantly slipping. And when you're trying to keep on a particular date, you have a schedule as a tool. You can say, oops, we just slipped, we're going to have to cut a little feature. And you can search through that list of 24 things that you're going to do and find the one that just doesn't really maybe absolutely have to be in the final product, and get rid of that. And through this constant elimination of not great ideas, you wind up making a better product. You know, they said from the beginning that we would be able to move in September 1st, and they're still saying that we're going to be able to move in September 1st.
With 3 weeks to go.
With 3 weeks to go. So technically speaking, they are on schedule. I'm a little bit skeptical. There's so much to be done here. Lights, floors. I think people have a very strong intuition that a schedule is like a best case estimate, and there's just as much chance of being early as being late. But actually what happens is a schedule is how long you think your thing is going to take, and then there's stuff that you forgot that you also have to do that takes longer, or stuff that comes up and stuff that interrupts you. And so in reality, schedules appear to always go late and never really go early. One common solution to this is just to take your list of estimates and multiply them by 3. And I've heard that, or multiply them by 2, or double the estimates. This is called the second guessing game, and the trouble with the second guessing game is you never know who else is doing it. So on your team, you might be second guessing by padding everything, multiplying it by 2, and then your boss multiplies it by 2, gives it to his boss, and his boss multiplies it by 2 and gives it to her boss, and so on and so forth. And then everybody just says, well, this is one of those padded estimates, so I'm going to divide it by 6, and you just wind up with a whole bunch of randomness. And so that doesn't seem like a very scientific way to approach things.
So making a schedule for construction, everything it's fairly traditional as far as how people think about scheduling a project. So one thing has to happen first, and then something else. You got to build the foundation, and then you start building up the skeleton of the building, and then you start building the facade and the interiors, and it's very orderly. Whereas with software, there's nothing that really needs to come first. There are sometimes prerequisites, but a lot of the time there's no particular order that things need to be done in. So with Copilot, for example, I can be working on the server side stuff while Ben is simultaneously working on the client side stuff, and I can have features ready ahead of him, or he can have features ready ahead of me, and we both can move on to something else until the other is ready. So it's a little more flexible in that way, but the flexibility also makes it harder. Doing one-click was kind of interesting. First of all, because we were in a different environment than we usually were. At the time, we were kind of halfway between the old office and the new office where we are now, in a temporary office downstairs. And so it's just the four of us. Hey Ben, we're scrumming in half, sure. To help facilitate this, we were doing Scrum meetings about every other day, and often we would do them every day. We would just get together, talk about what we'd done the previous day, what we were working on today, and what we expected to have done by tomorrow. And that helped us create a little bit of accountability towards each other to say, I'm going to get this done. And then the next day we would come back and people would say, okay, well, how did that go? Are you where you thought you would be? And either you would say, yes, I got it done, I'm working on this today, or you'd say, no, I ran into this particular problem. And at that point we could sit down together and figure out, do we need to address this problem? Is this problem harder than we thought? Is there a better way to do it? And then proceed from there.
After you finish the one-click stuff, you're going to jump onto...
Yeah.
Okay, cool. So
yeah.
So both of you guys, hopefully next week, will be working on decapitation.
Oh, unless something comes up today, then it should be fine.
Okay.
My plan was just to get a little more familiar with it, so I'm not wasting his time.
Right.
So I'm not really going to be making changes today. I'll just be looking through and making minor changes if I see things that jump out at me. But mostly it'll just be getting myself back into that code. And
we were on a mission to release a product in a few weeks, and that means there's a fairly high level of coordination needed. And if you don't want to interrupt each other, you have to figure out a way to do that relatively quickly. So the idea of a Scrum is that you take 15 minutes and you just talk about exactly where you're at and in terms of what each person is doing. And then you make course adjustments as necessary in those meetings. And then you don't worry about it again until the next time you get back together, so that you avoid interrupting people a bunch, and you also avoid sort of overthinking solutions to problems.
There are a couple of steps that I try to tell people to do to try to make your estimates work better and make your schedule really effective. Number one is to break down the tasks into very, very small units. If you have a task where each line item on the schedule is a unit of, let's say, 3 weeks of work, then you're probably forgetting a lot of stuff because you're not really thinking about the detailed tasks that you're going to have to do. You're just thinking about a chunk of functionality that you want to code up. What you have to think about is, what functions do I need to write? What classes do I need to create? What HTML pages do I need to code? What subroutines do I need to change? What APIs do I need to expose? And you need to enumerate and list every one of those things. And to do this accurately takes a certain amount of design. So you're going to need a spec that's pretty detailed. And that process of creating the relatively detailed spec and then going through it and figuring out what pieces of code am I going to have to write to correspond to this spec is really, really crucial, because that's where you discover the information that gives you the answer to how long is this going to take. It gives you actual, well, I got to do this thing and that thing, and I can estimate that this kind of thing always takes a couple of days. So as a rule of thumb, I would say every item on your schedule, every line item on your schedule should be no more than 2 days of work, at most 2 days of work. If it's any more than that, you need to break it down further, and you're probably not thinking about enough detail. And it's not just that you get a more precise number, you actually get a more accurate number. You get a number that is completely different and that reflects the reality of actually thinking about what all the things you have to do are and how long they're going to take.
Merge client department in a group is a very small change.
Yeah.
Yes.
The one above it can be a small change if we do the community users,
That's absolutely true.
or it could be a giant thing. And so I'm trying to figure
So
out.
to schedule Fogwig 7, we decided to take a list of all the features and bugs that we needed to fix, major bugs, and break them down into one of 4 categories. We said small is 2 days or less, medium is 2 weeks or less, large is a month or less, and extra large or giant was 2 months or more. So we did that. We figured everything out, and then we used that to get an idea of how many developer months approximately we were looking at for the next release. And then we looked at all the developers we had available and when they would be available to start work, and figured out a ship date based on that. So Bobak went and presented this calendar, the schedule, to Joel, and they looked at the date that EBS was predicting for when that would ship, and it was saying somewhere in the middle of December. So Joel said, how much can we cut this down? So Bobak came back to me and said, what if we were to try and finish plugins by sometime in the middle of November? Could we do it? What would we cut out? And how would we sort of hit that date? So I went back and I looked through all the cases in Fogbugs and reprioritized them and said, okay, if we do priorities 1 through 2, that's about 3 weeks. If we do up through 3, then we're looking at 5 to 6 weeks, which put us in the middle of November. If we do all the way to 4 and 5, then we're looking at the original date of middle of December. So we did that, and he said, okay, let's do priorities 1 through 3. So the point of the exercise wasn't to set a date and say, we have to make this date no matter what, and we're just going to have to work harder to meet it. The goal was to pick a date and say, what can we get done in this time if we want to ship by this date? And to look at, what the trade-offs are between shipping early and having to cut features. So we looked at that, we reprioritized based on that, and we did have to cut some features. We cut some mostly minor features or things that we weren't 100% sure that we would need.
Once you got these estimates, you can just try to add them up, and what you're going to get is a lower bound on how much time your project is going to take. And when I say lower bound, I mean a very, very low lower bound, because what you're forgetting is all the extra stuff that you're going to have to do that you completely forgot about. And that may be stuff that's directly related to the project. For example, you suddenly realize that you're going to have to rewrite some function that is a mess and can't really be used for the purposes that you thought you were going to use it. Or it may be unrelated to the project. For example, your hard drive crashed, and now you're reinstalling Windows and reinstalling the operating system and reinstalling your development environment and trying to find all your tools and get back to where you were 2 days ago. And that's just a pain, and you just wasted 2 days. Or it could be something like you're out sick for a day, and so your schedule should actually include estimates for how many days of vacation you're going to take, how many days of sick leave the average developer takes. All that stuff should already be in the schedule. Other tasks that you may have, other company responsibilities, you got committee meetings, you got interviews, you got lunch, you got all kinds of, you got the company picnic on the 4th of July, all that kind of stuff should probably be accounted for in the schedule. But still, this is going to give you kind of a lower bound on how long the thing really takes.
So what do you think about using a tool like Microsoft Project, which normally is used for construction projects, to estimate how long your software project is going to take?
Tools like Microsoft Project really were designed from the construction industry, where you know in advance that a drop ceiling takes 2 weeks to install. That doesn't really apply to software, and one of the biggest differences is that in software, as you discover unexpected things, they always add to the schedule. And so all the variation, the only kind of variation you get in a software schedule is that things took longer because you forgot something. And you don't get things took shorter because you were really lucky or something. When you do say drop ceilings take 2 weeks, that's because you've done it a lot of times, and they do take 2 weeks. And sometimes it takes 2 weeks and 1 day, but sometimes it takes 2 weeks minus 1 day. And so those schedules work out a lot better. And Microsoft Project really is designed for that deterministic world where you know how long things are going to take. Doesn't work so good on software projects. Software developers hate estimates and they hate creating schedules. They hate trying to estimate how long things are going to take because they just have no idea how to do it. Here at Fog Creek, we've developed a system called evidence-based scheduling, or EBS, that looks at historical evidence and creates actually useful estimates and good schedules for when you're really going to ship. And I found that even the grumpiest programmers are usually willing to go along with it. Traditionally, a schedule is something that you create where the boss says, hey, we're going to ship on May 16th, and so you write down May 16th, and then you calculate, well, May 16th, that probably means we're going to be in beta on January 16th, and you write this down. It has no bearing on reality. When you really ship, it might be May 16th, 2019, but it's not really, it has no basis in what you wrote down the first time. If you're going to implement a product and it's got 8 possible features and you've only got time to do 5, you want to do the 5 best features. And that means you need to know how long things are going to take. You need to know how much the cost is going to be of those features so that you can work on the features that get you the maximal bang for the buck. And you may also have some really important reasons to do schedules and estimates, like a client, and you need to figure out literally how much it's going to cost you to build this thing. So it's got to be done. We found a way here at Fog Creek. We've developed a system called evidence-based scheduling that we found works really well for creating schedules that are realistic, that you can actually hit, and that give you good information, and that aren't too much of a pain for the developers. So even the grumpiest developers are usually willing to fill out the timesheets and use the system of evidence-based scheduling. So evidence-based scheduling, or I'm going to call it EBS, looks at the evidence, the historical evidence, looks at track records, and it develops a schedule that's actually kind of reality-based as opposed to pulling numbers out of thin air. And instead of giving you a single ship date, the result of the algorithm is not we will ship on May 16th. The result of the algorithm is a probability distribution curve. The probability distribution curve shows you the probability that you will have shipped for any given date, and it rises because as time passes, there's a higher and higher chance that you will have shipped. You might see a probability distribution curve that's really, really steep, and that means a very narrow range of possible dates on which you can ship. And over a narrow range of dates, the probability of shipping goes up very quickly. Or you might see a really shallow distribution curve, and that means a wide range of possible dates on which you might ship. The shallow curve means you don't have a lot of good evidence and you don't have good estimators. And so the algorithm is sort of having trouble picking the ship date, whereas a steep curve generally indicates a lot of confidence that you're really going to be able to ship within that narrow range. So the probability distribution curve kind of gives you this additional piece of information, which is how good is the information that we have? How reliable is it? And how trustworthy is it? The other thing you can do with the probability distribution curve, of course, is you can look at that official date, that May 16th date, and see exactly the probability that you will ship on that date. And if it's really low, like 4%, you probably need to revise your plans. Similarly, you can say, if you're trying to figure out, I need to know when we're going to ship by with 90% probability, we need a lot of confidence, you can sort of look up the y-axis to 90% and then look across and see the date that you can ship with 90% reliability, which is probably going to be a bit later. The first step in evidence-based scheduling is to break down your work into very, very small tasks. I tell my developers that every task has to be smaller than 2 days, preferably a matter of hours.
The project that I was undertaking here is an improved customer database to power our new commissions structure for the new sales team. And it started out with a specification that Joel wrote, and he just handed to me. So I've got this nice wiki article in FogBugs that outlines all the pieces of how the sales team is going to get assigned new customers to salespeople. So the various sources that are going to generate new leads and customer contacts, emails coming in, incoming phone calls, new orders that come out of the blue from the shop website, etc. And he laid out some mock-ups of how the internal tools are going to have to work to interact with this improved database to provide ways to edit which customer is assigned to which salesperson, that kind of thing. And then from the functional specification, we created an outline of cases and fog bugs, which broke down each large task into smaller chunks and then eventually down into chunks of less than 2 days, most of them about half a day. And then the next steps were to prioritize those tasks based on what needed to be done first to support the other features and which needed to be done for the critical path of getting commissions paid.
You're breaking down a big amorphous feature, like let's say I'm going to make a spell checker, and I don't know what it's going to do and what it's going to have, but how long could that take? I don't know, 3 months? Let's put 3 months. When you've got a big task like that, you haven't really thought about what you're going to do. You haven't designed the feature, and you haven't thought about what individual tasks as a programmer you're going to have to do in order to implement that spell checker. But if I tell you, go break this down into one-day things, you're going to think, all right, I need to get a list of words in the English language, and I need to be able to break down my source document into individual words, and I need to look up each word in the dictionary, and if the word's not in the dictionary, I need to display a dialog box for the user, and that means I need a user dictionary if the word is not supposed to. And suddenly you're thinking about all this stuff, and you're thinking about all the individual steps you have to take, and you're much more likely to remember things and to remember how much work, and for the first time you'll actually be thinking of what you actually have to do in order to implement this feature. And so the estimate that you come up with is going to be much better. And the other big advantage here is that by breaking it down into small individual development tasks, you're actually thinking about things that you've done before. And so you may never have created a spell checker before, because if you had, you'd probably just be reusing it. But you've certainly created a dialog box before, and you've certainly broken down text into words. And so now you've got a bunch of little things that you've done before, individual subroutines, that are much easier to estimate because you've broken it down into atomic elements that you actually can estimate. Number 2 is the historical record. And that is, we need to figure out what you've done in the past and how good you are at creating estimates. Because that's going to tell us, that's going to give us the grain of salt that we have to take your future estimates with. So let's see what this looks like. Let's take, for example, a hypothetical developer who's just perfect. They're a perfect estimator and things always take exactly how long they thought they were going to take. Well, let's say that they have to work on a whole bunch of 2-hour features, and each of them actually took 2 hours. Wow, you're a fantastic estimator. In the future, if you put in any estimates, I'm going to take them at face value. This isn't so likely, but this is sort of, let's take this as the base case. A much more likely case and a much more common case is somebody who's a really good estimator, but they're eternally optimistic. And there's all kinds of sociological reasons why this might happen. You can be eternally optimistic because over time all kinds of things interrupt. You get phone calls, you've got meetings, you've got status reports, lunch, going to the bathroom, going to get coffee, doing an interview. Stuff just comes up at a certain constant rate in real life. And that causes you, when you think, that's about 2 hours, that a 2-hour thing might really spread to take the whole afternoon. And so you're kind of optimistic. And this is fairly common. So an optimistic estimator might have a whole bunch of 2-hour features. And when they go to actually implement them, they take 3 or 4 hours each. And then you've got a bad estimator. Somebody, and a bad estimator is not necessarily a bad programmer, although they might be. But typically a bad estimator is just somebody that's never estimated before, and they're just not so sure how to do it, and they're not used to knowing how long things really take. I've found that the developers on my team, when they're brand new, they start out, they're not such good estimators, but in a matter of about 6 months, they learn how to estimate really, really well, and they become a more typical, like an optimistic estimator instead of just a bad estimator. But a bad estimator has a bunch of things that they've estimated at 2 hours, and some of them take 1 hour, and some of them take 4 hours, and some of them take 8 hours, and they're just kind of all over the map. So the next stage is we've got a list of tasks. Step 1, we've got that list of tasks of what everybody needs to accomplish. And we have, for every developer, a set of historical velocities. We have a historical record that says what velocities they've achieved in the past. And we're going to combine these two using the Monte Carlo simulation, using the Monte Carlo method, to get the probability that we will ship on any given day. Here's how we do it. The Monte Carlo method says, let's simulate 100 possible futures, 100 potential futures. And each time we simulate a future, we're going to say, all right, this is what happened in this particular future. You had all these tasks to do. And for every future estimate that we have, we're going to divide it by a randomly selected velocity from the historical track record of that developer. So if I have a perfect developer, and they told me that something is going to take 4 hours, and they're a perfect developer, so all their velocities are 1, then when I divide 4 by 1, every time in the future, I'm going to get the same number. I'm going to get 4. And so in all of these possible Monte Carlo simulations, for all these 100 possible futures, I'm always going to get this task taking 4 hours. And I'm going to wind up with a great probability distribution, a nice sharp probability distribution saying I know exactly what I'm going to ship because I got great data. But if I have a perpetually optimistic estimator, and they always, let's say all their velocities are 0.5, because they're always optimistic by a factor of 2. Then when I divide, let's say they say they're going to work on an 8-hour feature, it's going to take 16 hours. And it's going to do that in every possible future. Now, the far more common example is that you've got numbers all over the map and you've got a whole bunch of different velocities for somebody. And the person has a bunch of high velocities and a bunch of low velocities because it's just sort of hard to predict the future and maybe they're not so good at estimating yet. Now what happens is when you do the Monte Carlo simulation, simulating 100 possible futures, in every possible future, you're choosing a different random velocity out of the historical track record of the developer. And every time, that's a different number. And so you wind up with very, very different schedules every time you do the Monte Carlo simulation. And you wind up with 100 different futures with 100 different ship dates, all of them with 1% probability. So that's the beauty of the Monte Carlo method. It lets you say, well, I need to ship by May 16th. Let's run the Monte Carlo simulation. We simulated 100 possible futures, and in 30 of those futures, we were shipping by May 16th. Well, now you know that you have a 30% chance of shipping by May 16th. That's how Monte Carlo simulation works, and that's how evidence-based scheduling gives you a probability distribution curve of how long, of when you're going to ship your software with what probability. When we were designing this algorithm, there was something we were really concerned about, which is that matter of timesheets. And there are two problems here. Problem number one, nobody wants to keep accurate timesheets. Problem number two, do you really have to keep it down to like the most minute level? Like if you're suddenly, I don't know, your MP3 player jams up and you spend a minute trying to fix your MP3 player, do you have to put that on your schedule? One thing you could do, and it would work, but it's kind of a pain, is you could actually record all these things on your timesheet. And you could try to estimate how long they were going to take in the future. It turns out that with evidence-based scheduling, you don't actually have to do this. It's really kind of cool. Evidence-based scheduling, all you have to do is keep the clock running on whatever feature you were doing when you got interrupted. So every interruption's time should just be charged back to the feature that you happen to be doing when you got interrupted, and you'll actually find that evidence-based scheduling then kind of works perfectly. You don't have to estimate your interruptions at all. Here's why it works. Let's look at a really typical example. Let's say that you have the crazy boss, the proverbial, the Michael Scott boss who comes in and interrupts you twice a day, wastes your time for about an hour working on something that has nothing to do with your actual job and serves no purpose whatsoever. So let me go through this theorem a little bit. You've got a bunch of tasks, and to make this simple, let's say that each of them is going to take exactly 1 hour. 1, 1, 1, 1, 1. You've got 8 things that are going to take an hour. And under normal circumstances, I would tell you that this is going to take a day. And you're a perfect estimator, just to make this example easier. And so when you said this is going to take an hour, they're really going to take an hour. And now you start filling out your timesheet, and you say, all right, this one really took an hour. And then the boss interrupts you, and so something took 2 hours. And you have to say, well, it took 2 hours. I estimated it 1 hour, but it took 2 hours. And then another thing comes up, and it takes an hour. So think about what you've got now is estimates of 1, 1, 1, 1, 1, 1, 1. But your actual times are 1, 1, 1, 2, 1, 1, 1, 2, because of those interruptions from your crazy boss. Now what do your velocities look like? Your velocities look like 1, 1, 1, a half, 1, 1, 1, a half. Okay? And that means your historical record, that bucket of velocities that we're going to use in the Monte Carlo simulation, accurately captures the exact probability and the exact impact of your crazy boss. It's already in there. And so the next time you have to do 8 1-hour features, we're going to go back to your historical record. We're going to see a whole bunch of 1-hour things that you have to do. We're going to divide them. And sometimes when we do simulations of the future, we're going to be dividing them by 1 and nothing will change. And sometimes when we do simulations of the future, we're going to be dividing them by a half. And the probability that we divide by a half, i.e. multiply by 2, is exactly the same as the probability that your boss is going to interrupt you as shown by the historical record. So you haven't even kept track of what those interruptions are or how they're spending time, but they're incorporated into your historical velocities with a great deal of accuracy, so that when you do future predictions of how long things are going to take, the Monte Carlo simulation correctly incorporates that and will build a schedule that is realistic for the types of interruptions that you actually empirically get in your environment. There are a few different ways you can use evidence-based scheduling. Number one, it helps you find the bottleneck or the critical path on your team. Usually there's 1 or 2 people on your team that have way more work than everybody else, and they're going to be the last ones to finish their features. Well, evidence-based scheduling, you can quickly break down each project per developer and see when each developer is going to be finished. And you can find the developers that have the most work and reallocate some of their work to someone else. But it also lets you find the developers on your team who are not so good at estimating. Now, I've found that there are really good estimators and there are poor estimators, and just about anybody can learn to become a good estimator in about 6 months. So evidence-based scheduling will show you for your good estimators a very, very steep probability distribution curve, a very narrow range of possible ship dates. And for the bad estimators, it'll show you a very shallow distribution curve, a very wide range of possible ship dates. And so you can find those bad estimators with a wide range of possible ship dates, and you can try to help them, and you can go over their list of estimates, and you can try to encourage them and train them to be better estimators. And certainly you can identify where the risk is in your schedule. The other thing you can do, of course, is cut features so that you ship on time. And this is something that you always have to do. But think about the benefit of evidence-based scheduling is that now you can cut those features at the beginning of the process, not at the end of the process. What happens if you got 10 features that you want to do and you imagine you're going to be able to do them all? And you start the process and you do the 5 most fun features that the developers most want to do because they're the funnest to code. And then you have to ship because you've run out of time. And now you have to cut 5 features, but they're not the most important 5. You might be cutting some pretty important features. You're not cutting the 5 features you want to cut. If you use evidence-based scheduling, you can see at the beginning of the process, I better cut 5 features in order to meet my date. And you can choose from the entire selection of features what the worst features are, the least important features, and you have a much better chance of making a great product that has the right features in it. There are 2 kinds of unpredictability, 2 kinds of risk in a software schedule. The first is the risk that your estimates weren't very accurate, and evidence-based scheduling completely eliminates that problem, completely solves that problem, gives you a good schedule no matter how good you are at estimating. But the second kind of risk is the risk that you're going to have what we call creeping featureitis. You're going to keep adding features to the product while you're working on it, which will cause the schedule to be impacted. And so at the beginning of your schedule, EBS might have told you that you got a really good chance of making your May 16th date, and by the time April rolls around, you've added so many darn features that EBS is now telling you you're going to ship in September. The only way to control this, really, is to look at how the ship date has changed over time. Fogbugs, for example, will give you a ship date over time chart that shows you every night what was EBS reporting as the ship date. What you probably will see is in a typical project where you're not adding work, you'll see a nice straight line. Like, okay, we're not really adding much work, and so that gives you a lot of confidence that you're going to ship on time. If you're adding features, you're going to see this because that curve's going to go up. The ship date over time is going to get later and later and later. And if you've noticed a 45-degree angle where the ship date over time goes up by 1 day for every day, you're never going to ship. You're always 6 months away from shipping. And this is a sign of a project that is never going to produce anything and is not going to converge, and it's pretty important to probably try to bring that in. I think that estimates should always be created by the programmer who is going to do the work. It's very important that the programmer that's going to do the work estimate their own features. When you have an estimate that's done by a manager, it reflects way too much wishful thinking. When you have an estimate that's done by somebody who doesn't know the programmer in question, it's just not going to work. And so the best way to divide responsibilities on the team is that every programmer is personally responsible for their own estimates, for their own features that they're going to be working on. They're going to break it down into the list of tasks. They're going to estimate each of those on an hourly basis. Number 2, you constantly want to keep this data up to date. You want to re-estimate. So every once in a while, you need to go into your list of tasks that you're working on in the future and think to yourself, is that even the right list? Have additional things come up? Are there additional things that I know I'm going to have to do? And as time goes on, you may suddenly discover that some things are going to be a lot harder than you thought, some things are going to be a lot easier than you thought. And so you want to concentrate as you go along in the project on keeping that data up to date at all times. If you find a bug, fix it as soon as you find it. Fix it as soon as possible. Even if you're working on something else, put that down if you're working on new code. I always recommend fix bugs first before you implement new code. The reason for this is simple. First of all, you're more likely to remember things and so if you're fixing a bug in some code that you wrote, that day, it's trivial, it's very easy. If you're fixing if you're fixing a bug in code that you wrote a couple of days ago or a week ago, you might have to page back in all that stuff into memory, try to remember what it was you were working on. If you're fixing a bug in old code, it takes forever. You're doing archaeology, trying to figure out what the code does. You don't even know where it might live, what file to look at, and it takes you much, much longer to fix it. All else being equal, bug fixing time is smaller and it's a lot less painful if you do it quickly rather than if you do it much later. And so you always want to fix bugs first before you implement new, fresh code and create new bugs. When you fix a bug for a feature that you've recently implemented and you fill out your timesheet, you should charge the time for that bug fix back to the original feature that you had implemented. For example, if I have a feature that's to implement a certain dialog box, I estimated it 2 hours. Indeed, it took 2 hours, and I implemented it, and it took 2 hours. And then I spent another 4 hours fixing all the bugs in this dialog box. I want to charge that time back so that the evidence-based scheduling knows that it really took 6 hours to implement that feature that I thought would take 2 hours. And if you do this consistently, then what you get, the results that you get, is that evidence-based scheduling will tell you how long it takes to deliver a bug-free product, instead of trying to estimate separately how long it takes you to get the code working the first time, and then how many bugs are we going to find, which is impossible to know, and then how long is it going to take to fix them, which is really impossible to know. So with evidence-based scheduling, as long as you're charging all your time back to the original task when you find bugs, whatever those bugs may be, then evidence-based scheduling will get the right historical information. And that's going to teach evidence-based scheduling. When Joel says 2 hour dialog box, better record 6 hours, because that's how long it takes to get a debugged dialog box. A really important principle is that an estimate that a developer created for how long something is going to take is not a basis for negotiation. Under no circumstances should you ever negotiate over estimates, because it's just not going to work. You have an estimate. Estimates are hard enough to get right. You come up with an estimate, this is going to take 2 weeks. And then what always happens is that the sales team or the management or the boss comes in and says, can't we do this in 1 week? And now it's basically a lose-lose situation. You can say, all right, fine, 1 week. And you change your estimate to 1 week. How long does it take? 2 weeks, right? So what's the point in changing the estimate? All you're doing when you negotiate over estimates is distorting information that was really, really hard to get in the first place. So instead of negotiating over estimates, use them. Just say, listen, this is how long it's gonna take. And maybe we'll be lucky it'll take a little bit less time, although I've never had that happen. And maybe we'll be lucky and it'll take a little bit longer. But we have to use this information as soon as you get it. An estimate is this rare opportunity to peek into the future and find out what's going to happen. And if you start negotiating, then you're not getting realistic information anymore. You're throwing away that useful information. You're creating a fantasy scenario, which might make you feel better, but is going to cause you to make the wrong business decisions.
Typically, if managers don't come from a software development background or are not particularly thoughtful and careful about how software development does, if they haven't come from a software development background, the managers, whether the project managers or higher level executives in the company, just decide arbitrarily. I mean, they might as well throw a dart at a wall, at a dartboard, or a calendar, I should say, and just, because that's what it feels like. Oh, we'll be done with this on August 8th, without regard to how many people they have, the level of ability that those people have to get the work done, the various competencies, and whether it's just physically possible to get it done, to QA it, to bug test, to fix those bugs. And what ends up happening in those situations is they've got this deadline, it's just like August 8th, it just has to be done, irrespective of any other considerations. And so people end up just burning themselves like crazy. They work 60 hours, 80 hours, they go in various kinds of phases of this sort of overkill death march drive. I've seen it happen over and over again, and a lot of times people meet it, like it gets done, but the consequence, the cost of doing that is not always apparent to these managers, and it's not always, it's never when they're pushing for those sorts of things. It's never accounted for in the cost of actually doing a project. What ends up happening, I think the guy talks about it in Peopleware, they end up doing, I think he calls it compensatory undertime. So they work 60 hours a week for a month, they're going to make that time up through decreased productivity later because they're burned out, they're mentally burned out, and programming is an activity that takes a high degree of concentration and focus, and if they've burned it like that, 60 hours a week for a month, for example, they need recovery time, and that recovery time is very costly on the other end.
If the estimate, as it inevitably is going to take you too long, what you're going to need to do is cut features in order to ship on time, if that's what you need to do. Let me tell you a little story. When I first started working on the Excel team, we were working on Excel 5.0. The first thing we did is the design team that I was on, the program management team, we came up with a gigantic spec. We gave it to the developers crunched it for a couple of weeks and came back with an estimate that this spec would take 3 years to implement. And we said, 3 years, we only have 1 year. And we realized that we were going to have to cut about 2/3 of the features. This was a very, very painful process. Every feature that we cut was a gem. It was a beautiful feature. It would have been awesome. And we cut them anyway, and we felt like we cut to the bone, and then we cut some more, and then we amputated a couple of arms, and there was just blood all over the floor. But to make the process go a little bit smoother, we decided that we would cut some features, but some features would just be flagged as Excel 6 features. We were working on Excel 5. Some of these, let's just punt them. We're not really cutting it. We're just going to do it a little bit later. And that made everybody feel better. They didn't feel like they were cutting. They just felt like they were punting. So having done this, we then worked on Excel 5. We finished it. We shipped it on time, incidentally, without too much more cutting. And a colleague and I were charged with creating the Excel 6 specification. So we said, hey, this is going to be easy because we have that list of features that we cut from Excel 5. So let's take that list and let's use that as a starting point. And we got that list and we started going over it. And when we thought about it a year later, all of those features seemed really dumb. We were actually kind of thankful that we hadn't done them. Some of them were just the craziest ideas. They would have been support nightmares, or they just weren't very valuable. The truth is, when we had come up with the initial vision for Excel 5, we had actually come up with some good stuff and some dumb stuff. And then we cut all the dumb stuff and we shipped an awesome product. And doing the dumb stuff in Excel 6 wouldn't have really made sense. And we actually went back to the drawing board with Excel 6 and tried to refigure out some good features to do there. And that's actually what we implemented. So the most useful thing about a schedule and the discipline of a schedule and looking at the schedule in advance is it enables you to cut features to the bone very, very early on in the schedule, which is how you make awesome software.
I've already settled in.
You've already settled in.
I brought my ladder.
Yeah, Brett's totally taking one of these.
Oh, I fire.
This is great.
This building inspector?
No.
You're not in this area.
Oh, okay.
Did you know that?
No, I
Oh, you didn't see the email?
Congratulations on the first.
But I want the monitor mounted right here, and that would be perfect because I can just see it all day.
Yeah, storage is by the fish tank. Kristen goes turn this way.
Are you excited about this thing?
Yeah.
Oh wait, check this out.